Bismillahirrahmanirrahim. It's a pleasure to start the A-level physics with grade 11 students all over Maldives. I am Ania Rashid from Addu High School. The name of the qualification that the Maldivian students will be sitting is the Pearson Edexcel International Advanced Level Physics. Now, this specification is a modular specification which is going to be written over a course of 2 years. And at the end of this lesson, I would like all students to be able to identify at least the main sections of the specification. The specification is very important. It's an important document that all students need to be very familiar with over the course of the next 2 years. Also, I would like to highlight the importance of mathematics, of practical skills, and also of your written communication when you are studying the specification, as well as when you are sitting the written assessments at the end of grade 11 and grade 12. At the end, I would identify the levels of assessment in each specific modular unit. Also, I would give some tips for students so that you can adjust your revision over the course of the next 2 years for your maximum benefit. At the end of grade 11, students will be sitting 3 units, a qualification level that we call the International Advanced Subsidiary level. There are 3 units in this level, which is Unit 1, Unit 2, Unit 3. Unit 1 is the content involved is mainly mechanics and materials from O levels. If you can relate to this, it would probably be things like Newton's laws, energy calculations, that kind of thing. When we move on to Unit 2, it will be the content is mainly waves and electricity, both of which you will be somewhat familiar with from your O levels. However, it will be at a much advanced level. Practical skills in physics, I will discuss in detail over the course of the lesson. International advanced level, the full qualification you will get only after you sit the A2, which is the examinations that you sit at the end of grade 12, which is the units that you need to write is Unit 4, Unit 5, and Unit 6. Further mechanics, fields, and particles. Fields, again, is something that is familiar to you. Electricity and magnetism you have already done in your O levels. However, again, here it will be at a much advanced level. However, particles, the particle physics is a completely new topic, and many students kind of are intimidated by it. However, it is one of the easier topics in all of the physics content that will be taught. Unit 5, thermodynamics, radiation, oscillations, and cosmology. Out of this, again, cosmology is something totally new to all O-level students, but it's a topic that many students actually look forward to studying. It's all about the stars and the universe and the age of the universe and things like that, which everybody is really interested in. And the last, again, the practical skills part, I will discuss it with you in detail over the course of the lesson. It is also important that students note that Unit 1, Unit 2, Unit 4, and Unit 5 are the 4 units which has physics concepts in the sense that there are objectives of physics written down. However, Unit 3 and Unit 6 are 2 practical papers, or alternative to practical papers, and these 2 papers, the content for these 2 papers needs to be revised along with the content units, which means when you are studying Unit 1, you will have to revise and kind of understand and be able to apply the practical skills of all the content that is being taught in Unit 1. The same goes for Unit 2, Unit 4, and Unit 5. So it's very important that students do not only focus on the content or the knowledge level that is being taught in the content level units. It is also important, equally important, that students focus on the practical side as well. I have just written down the names of the units for you to have a kind of overview. Now what you see on the screen is the content and the practicals that will be tested. Now this is a very important part of physics. Physics, it can be said the language of physics is mathematics. Without mathematics, physics is very difficult to understand. If you take a very simple example, in O levels you have done velocity is equal to displacement by time. The concept of velocity itself is defined as a mathematical equation. Now, you will find that over the course of the 2 years, you will come across equations that are more complex and more complex. However, do not try and focus on what the equation looks like, because it may look like a really complex thing. When you focus on what it looks like in the physical world, that is where physics starts making sense a little more. Actually, what happens is many students are intimidated by the mathematics. The physics concept, underlying concept is easy, but because of the mathematical equation that looks a little complex, you have a kind of hesitancy. Now, in order to overcome that hesitancy, you need to know more than what the equation looks like. You need to know more than how to rearrange the subject of the equation and find an unknown quantity. You need to know more than that. There are several mathematical models in physics. I will show you an example to show you how you should approach physical concepts and use the mathematics to visualize things in our physical world.
For the equation y is equal to 1 by x squared, as x increases, you should see that y should decrease. But as x is raised to a power of 2, the decrease cannot be linear, which means the graph cannot be a straight line. Now, there are three ways to represent this equation. When you see the numerical representation, you can see very clearly, that is the y-axis, the numbers are decreasing as x increases. Now you can draw this data represented graphically. Now what it means to say that y against x graph is that on the y-axis you are taking y to be y, and on the x-axis you are taking the x-axis to be x. Now we know that it is 1 by x squared that we are drawing, and then we get a graph that looks like a curve with a decreasing gradient. Now the same equation can be drawn, a graph can be drawn differently. You can draw a graph of y against 1 by x squared. Now what will the change be like? Let us have a look. On the same graph y against x, I have also drawn the y against 1 by x squared to show you the difference. Now the red line is actually when y is equal to x, because our equation is y is equal to 1 by x squared. That red line I will get only if I draw for the equation on the graph for on the y-axis y, and on the x-axis this is 1 by x squared and not x. So for a graph of 1 by y against 1 by x squared, you will get a straight line because y is equal to 1 by x squared. Now this equation hasn't changed. What has changed here is the label of the axis. So you should be very careful when you are representing data on graphs. You should be very careful about what the axis shows you, because the same equation can be represented in different ways on different graphs. Now the third way of representing this y is equal to 1 by x squared as a physics concept, I will walk you through using the aid of a picture. Visually, this data looks like, let's write down the equation, y is equal to 1 by x squared, where y is brightness and x is distance. Now, when distance is 1, the brightness is 1. Let's say that this is a light source, and from the light source there are 10 photons of light escaping. I have drawn 10 dots on that window over there. Now this 10 dots at a distance of 2 is spread over a distance over an area 4 times the area of this original window. So when this 10 is spread, you will find approximately 2 to 3 dots on the same sized window. So you will see that it has dropped by 1/4. The brightness has dropped by 1/4. Now the same 10 photons is spread at a distance of 3 over an area of 9. So you will see that it has spread further, and on each window you will see you will have a maximum of 2 on the area of the same size. So what I'm trying to tell you here is, in our physical world, we should be able to visualize that when we see this equation, we should be able to see in our minds what is happening with the physical quantities that we are talking about. Sometimes, initially you might find this a little difficult, but over time and with practice, it gets much easier. And once you reach that level of understanding, physics is actually a very easy subject. Getting there might be a little work.
Now, I would like to take you through what is involved in practicals in A-level physics. Like mathematics, practicals goes hand in hand with physics concepts. You can't study physics without learning the practical skills and techniques that are involved. When we come to practicals, these are the things that you need to focus on. Apparatus and how to use them. These are standard apparatus. Very ICT-based practicals are there. This device that I'm holding in my hand is called a LabQuest. This is a digital data logger. Multiple electrodes can be used along with this. You can use a motion sensor. This will, if you connect the motion sensor to the data logger, you can calculate the velocities, the speeds, the times automatically of a moving object. You do not have to measure it using stopwatches and such. You can also connect what we call a light gate to the data logger. What this light gate does is, if I drop an object through the light gate when it is connected to the data logger, there's an infrared emitter and an infrared sensor over here. So when this one obstructs the infrared ray, the data logger will record the time at which it is obstructed, and when it completely falls through, then the data logger will again record the time at which the object has completely fallen through. So you will know the time it took for this marker to fall, this distance to fall under gravity. In the sense that all these ICT makes it more easier for us to collect data for physics practicals. And your written examination papers also expects you to know how to use these apparatus, and also expects you to know the advantages of using these over more analogous measurements that we take. There are other sensors. This sensor here is a microphone. When we try to find the speed of sound, this will come in useful. There are multiple other sensors, including sensors of magnetic field, sensors of pressure, volume, temperature. There are multiple sensors that go along with what we call the data logger. You need to know practical techniques to collect data. You need to be able to design your own experiments. You need to be able to do data analysis and interpretation, which is something, again, I discussed previously in the mathematics side. That is mostly what will be data analysis and interpretation. And then you need to be able to draw your own conclusions from the data you have collected. Another very important thing, when you see the bottom right-hand corner, this software, the tracker software, is something that all physics students need to be very familiar with. It is included as one of your core practicals. Out of 16 practicals, one is required for you to do video analysis using tracker software. And over the course of the 2 years, you will slowly learn how to use these by yourself. Now let's talk a bit about assessment before we wind up. Now assessment has been in the syllabus is at 3 different levels. The most basic level is knowledge and recall, and we need to understand that at A levels, knowledge and recall amounts to only 30% of what is being tested, which means if you know everything in your syllabus, if you can recall everything, you still get only 30%. Majority of the marks in A-level physics goes towards applications. Again, applications are in 2 different levels. There will be contexts that you have never heard of before, maybe even I have never heard of before, but you should find something, you should recall all the physics concepts and see what concepts relate to that context. And also, it is also very important that when you are talking about the same context, no matter what the context may be, if it is the same concept, the terminology we use to explain it needs to be the same. It's a very important part of scientific writing that you need to use correct terminology with varying contexts if the concept is the same. And the last objective over there, experimental skills, including analysis and evaluation of data and methods. This objective is normally tested only in the Unit 3 and Unit 6 papers. Application, analysis and evaluation, and also the knowledge and understanding is there also to some extent in the Unit 3 and Unit 6 papers. However, the majority of the knowledge tested and the application and the analysis and evaluation comes in the content-based papers, which is Unit 1, Unit 2, Unit 4 and 5. How will you know what a question is asking you? Is it knowledge? Is it application? Or is it a higher level than that? Is it evaluation? There's a whole section in the specification that says, that explains the command words used in questions in A-level physics. For example, something like describe, state, draw, write. These are knowledge level questions. It's a simple matter of recall and writing down. Calculate, determine, explain requires that you do a little more work, use information from the question and interpret it. And also the last one is to assess, that means make your own judgments about something. So at the 3 levels, very important when you are revising to focus on all 3 levels of assessment. Now, transferable skills include all what I have been saying so far. If you look at this, you will see that each of these has been discussed in detail previously, but there's a section in the specification explaining these. I'm not going to go into the details of this. Just a few tips. Start revising early. Maintain your own set of notes because contexts vary. Go through as many resources as you can. And when I say that, a few of the resources include your textbook, your lab book, past papers, marking schemes, examiners' reports that are available on the Pearson Edexcel website. Well, I think I have talked a lot. And to conclude, I will say that even though physics looks daunting to many, do not hesitate to ask your teachers questions. The more questions you ask, the more you clarify, the more active you are in your learning, the better, because the more you will learn that way. Thank you for listening and hope to meet you in another lesson, maybe another week.